Welcome to Sairam through YouTube channel. Let us discuss Model 1 Introduction to Smart Grid Architectural Design. In that, we have a multi agent system, MAS technology, continuation of previous video. MAS are the computational system in which several agents cooperate to achieve desired tasks. See here, the smart grid is depends upon several parameters, not only one parameters. Depends upon from the generating station to the consumer side, right? So it involves distribution and transmission. So where exactly the power will be flowing and how much drop will be occurring and how much losses will be occurring. It will be monitoring by using this smart grid. And even though if suppose the performance of MAS can be decided by the interaction among the various agents. It's like a, I mean, like depends upon customers and stakeholders. And then, for example, I'll tell you there is a generating stations from your rooftop of your building. So that's a integration of a generating station. So it involves several parameters. I mean, like several procedures will be there. Agents cooperate to achieve more than if they act individually. So I mean, agents must be cooperate. I mean, like power generation or transmission distribution, not individually. Individually, you'll not get that much outcomes, right? So that's why we have a multi agent systems. MAs are the preferential choice for developing distributed. So it's a development of a distributed generation and generation also, and implementation of power system into smart system, right? Next, we have a microgrid and smart grid comparison. See, a microgrid in the sense a generation of power supply in micro level. Like, for example, I'll tell you, if suppose you are having a building, you people are using a solar power plant. So that power plant power generation directly goes to the grid, and then so I mean, adding so many power plants. I mean, like so many small power grids into the main grid, and a smart grid comparison will be there. So smart grid, microgrid, small number, and a smart grid is the intelligent power supply system. It's a totally I mean, like monitoring and controlling must be like automatic. Smart grid, basically microgrid is local island grid that can operate as a standalone as a grid connected systems. So I think research has been conducted to understand the difference between the microgrid and smart grid, right? See, the similarity is same because smart grid in the sense addition of solar, wind, hydel power plant. I mean, like at present solar and then wind we are adding, right? So it's like a microgrid also. So this research is going on. So for that, and next there is a introduction to load flow studies. Load flow studies we have in the seventh semester Newton-Raphson method, fast decoupled method, and then Gauss-Seidel method. So I mean, like iteration techniques we used for the least error and then least load flow analysis and then expansion extending. So that also included in the smart grid. Load flow studies are critical to system planning, system operation. For example, data peak load condition assists planners in determining the size components. I mean, like, so whatever we are discussing in the power system analysis 1 and 2, there is a extension of a power supply and expanding and planning and improvement, right? So conductors, transformer, reactors, and capacitor. Conductors like load flow studies are also affected, and transformers transport the power from one place to another place. Reactors for like increasing the levels, and shunt capacitor for output must be like without harmonics or something else like that we are going to discuss. Next, there is a challenges to avoid uh, load flow in the smart grid and weaknesses of the present load flow methods. Current legacy methods have weaknesses that need to be addressed prior to their use. In analyzing the smart grid performance and operation, four fundamental questions should be answered, right? So, what are the special features of the smart grid compared to the legacy system? I mean, special features we have to, invent, right? And what computations are needed in the case of a smart grid? What specific directions are needed for developing the new power flow? What new features of the load flow make it suitable for smart grid performance and evaluation? So these four questions are needed for improving the power system into the smart grid. Uh, I mean, specific features needed, computations are needed, and specific directions are needed, and new features of the load flow needed, right? So you have to answer for that questions. Load flow states is the art, classical extent and uh, formulation and algorithms. The traditional load flow techniques used to distribute the load flow are characterized by distribution system or radial or weakly mesh network structure, high XPR ratio in the line impedances, single phase load handled by the distribution load flow program, and distributed generation. Distributed generation, I'll tell you an example, best example, right? So, best example is our college. That's a distributed generation station, like generating generation power plant. So we are generating 212 kilowatts power generation. That's a integration with the distributed generation, I mean like integrated with the government, I mean like the power supplier. So it we are generating like 212 kilowatts per annum, and it directly goes to the um, uh, government, and they are giving like subsidies or whatever, that's secondary. But so we are producing, but we are not using batteries, okay, batteries for charging, and we are not utilizing it. It will go to government, and then whomsoever needed, I mean power supply, whomsoever falling in like load shedding or power required more. So that I mean like to fulfill that, we have generating stations also, and that is combined with the government and generating stations, right? um, that's the one thing, that's the integration of a distributed generation. Other renewable generation like wind, solar, and nuclear, thermal, and hydel power plants, and gas power plant, diesel power plants also will be there. And co-generation power supply, heat thermal, and I mean like adding of more number of generating generations. And some load centers, distributed system with many short lines segments, most which have low impedances values. So low impedance in the sense, impedance must be low. Suppose current will be high, if you want to increase, so definitely it's low value, right? So and another one is there, high X by R ratio. X is a reactance, and then resistance ratio of the line impedance. If suppose X by R ratio increases, definitely the load flows or whatever improvement will occur. And and distribution system are radially or weakly measured network structure. So radially in the sense like one master control will be there. So radially it will be, I mean like in a circle it will be controlling. And next is a single phase load handling by the distribution load flow diagram. So single phase load handling is also done by this, and um, handled by the distribution load flow program. So its overall structure needs like a load flow state of the art, and classical extended formulation and algorithms. Algorithm in the sense step by step procedure. Formulation in the sense formatting, like one to one, based on the procedure, based on the theory. So formatting the structures, and then extended section. So even though analysis, if you've done, definitely it's extending the operations, like if suppose power supply needed somebody more in the power plant, so it should be extended to their extent, I mean their satisfaction, load flow state, and this is the concept.